Our world is changing. We see it in the news and feel it in our communities. Intense rainfall events are becoming alarmingly frequent, overwhelming our cities. This is a clear and present danger that demands our immediate attention. The systems we built to protect us are struggling under the pressure of a shifting climate. The water that rushes across our urban landscapes carries a hidden burden of pollutants, degrading precious aquatic ecosystems. We have spent centuries sealing the ground beneath our feet. Concrete and paving have replaced the soft, porous earth that once absorbed rainwater naturally. This convergence creates a perfect storm. We are faced with a future where flash floods become a common feature of urban life. It's a stark picture, but it is also a powerful catalyst for change. It forces us to look beyond the concrete and pipes and to seek out smarter, more harmonious ways of living with water. We now need a fundamental rethink of how we design, build and manage our cities from the ground up. Facing immense stormwater challenges, a new philosophy is emerging: sustainable drainage systems, or SuDS. SuDS treats rainfall as a valuable resource, managing it close to where it falls. At its core, SuDS mimics nature's processes. SuDS applies these principles to our built environments using techniques like green roofs and permeable pavements. This reduces flood risk and improves water quality. SuDS transforms drainage into a visible, multifunctional asset. It enhances our surroundings, making our urban centers more pleasant. SuDS is a flexible toolkit tailored to the specific needs of any location. This video will explore the fundamental concepts that underpin SuDS. This video is designed to be a definitive resource, taking you from the core principles of SuDS right through to the practical realities of putting them into the ground. Our journey will be structured and thorough, ensuring you gain a complete understanding of this vital subject. We will begin by delving deeper into the problems with our traditional pipe-based drainage systems, highlighting exactly why they are failing us in the 21st century. We will then formally define what SuDS are, exploring the key goals of slowing the flow, improving water quality, and enhancing the urban environment. This foundational knowledge is crucial for appreciating the elegance and effectiveness of the solutions that follow. From there, we will embark on a detailed exploration of the individual components that make up a SuDS network. You will become familiar with the clever design of permeable pavements that allow water to soak through, the gentle vegetated channels known as swales, and the beautiful hard-working rain gardens that can turn a street corner into a miniature wetland. We will also look at larger features like detention basins and the vital role of green roofs in managing rainfall right at the source. For each component, we will examine how it works, where it is best used, and what it looks like in the real world, providing you with a complete visual and technical vocabulary. Of course, a great idea is only as good as its execution. That is why we will dedicate significant time to the critical aspects of design and construction. Good design requires a deep understanding of the site, from its soil type and topography to its rainfall patterns. We will discuss the key considerations that engineers and designers must weigh, including the powerful software tools they use to model and predict how a SuDS scheme will perform. Following design, we will walk you through the best practices for construction, offering step-by-step guidance to ensure these systems are built correctly, function effectively, and stand the test of time. Finally, we will bring everything together by looking at real-world examples and the tangible benefits they deliver. We will analyze the costs and long-term value of SuDS, demonstrating how the initial investment pays dividends in flood protection, environmental health, and community well-being. We will also cover the essential, though often overlooked, topic of maintenance to ensure longevity. Through inspiring international case studies, you will see how cities around the globe are successfully implementing SuDS to create more resilient, sustainable, and beautiful places to live. So, if you are ready to explore the future of urban water management, let's begin. For over a century, urban rainwater management has been governed by a single principle: get rid of it as quickly as possible. This flush and forget philosophy was born in an era of rapid industrialization. The primary goal was public health, to prevent streets from turning into quagmires. Engineers developed vast networks of underground pipes designed to capture every last drop of rain. It was a triumphant feat of civil engineering, This system is built on the idea of collection and conveyance. This approach treated rainwater as a waste product rather than as a natural part of the local environment. This created a profound disconnect between our urban spaces and the natural water cycle. We paved over the very soil that once absorbed the rain. However, we are now beginning to understand the severe and unintended consequences that this focus has created. Conventional drainage, while efficient, can harm the environment. Rainwater becomes a chemical sponge, collecting pollutants. This polluted runoff is channeled into waterways, often untreated. The first flush delivers a high concentration of pollutants, harming aquatic life. The sheer volume of water causes physical damage, eroding riverbanks. By preventing rainwater from soaking into the ground, we starve our aquifers. Drainage systems create floods and contribute to drought, disrupting the water cycle. Conventional drainage networks are now facing a challenge they were never designed to handle: climate change. We are witnessing an increase in extreme rainfall events. These downpours overwhelm the underground pipe network. The system fails, leading to street flooding. Water spills into our homes and businesses. This is a direct result of a rigid system being pushed beyond its breaking point. Urban expansion worsens the problem with more impermeable surfaces. Combined sewer overflows discharge untreated sewage into rivers, causing pollution. The traditional drainage model lacks resilience. We need a new, adaptable approach that works with nature. Sustainable drainage systems, or SuDS, offer a fundamentally different way of thinking about rainwater in built-up areas, treating it as a valuable resource to be managed rather than a waste product to be disposed of. SuDS aims to slow it down, store it, clean it, and allow it to be absorbed back into the environment, mimicking the natural water cycle. SuDS applies these principles using a toolkit of specially designed features. Even the roof of a building can be transformed into a living green roof that acts like a sponge. SuDS is about moving drainage to being a visible, integrated and multifunctional part of the landscape, creating urban spaces that are also more attractive, biodiverse and enjoyable places for people. The SuDS philosophy is brought to life through 4 key objectives, often referred to as the 4 pillars. Managing water quantities slows the flow to prevent flooding. Improving water quality filters pollutants through soil and vegetation. Providing amenity creates valuable public spaces. Enhancing biodiversity creates green spaces and habitats for wildlife, making our cities richer and more ecologically resilient. When the 4 pillars of SuDS, quantity, quality, amenity and biodiversity, are successfully integrated into a design, the result is far more than just an effective drainage system. It becomes a catalyst for creating better places. A street is no longer just a corridor for traffic. It can be lined with bio-retention planters that manage runoff while also calming traffic, greening the view, and providing a habitat for pollinating insects. This multifunctional approach means that the investment in drainage infrastructure delivers returns across many different areas, from environmental health to social well-being and economic value. It is a truly holistic way of thinking about urban design. This approach fundamentally changes the character of our built environment. Instead of grey, sterile landscapes dominated by impermeable concrete and asphalt, SuDS helps to weave a network of green and blue spaces through the urban fabric. These features introduce the textures, colours and sounds of nature into our daily lives. The presence of water, whether in a beautifully planted rain garden or a permanent retention pond, has a proven calming effect on people. These spaces become natural focal points for communities, places where children can learn about nature and neighbours can meet, fostering a stronger sense of place and local pride. Furthermore, embracing SuDS contributes directly to building climate resilience. Beyond managing the intense rainfall events that are becoming more common, the green infrastructure associated with SuDS helps to mitigate other climate impacts. The vegetation and water bodies have a cooling effect, reducing the urban heat island phenomenon that can make cities uncomfortably hot in summer. The plants absorb carbon dioxide and filter air pollutants, improving local air quality. By replenishing groundwater levels, SuDS can also help to make communities less vulnerable to periods of drought. It is a forward-thinking strategy that prepares our cities for the environmental challenges of the future. In essence, sustainable drainage systems are a powerful tool for regenerative design. They don't just solve the problem of runoff, they actively improve the places where they are implemented. They take a liability, excess stormwater, and turn it into an asset that can be used to create ecological value, social amenity, and beautiful landscapes. This is why SuDS is now being championed by planners, architects, and engineers around the world. It marks a move away from the single-purpose utilitarian infrastructure of the past towards a more intelligent, integrated and life-enhancing approach to building the cities of tomorrow. It is engineering in service of people and the planet. The most effective way to manage rainfall is to deal with it the moment it arrives. One revolutionary solution is permeable pavement. Beneath the surface lies a system designed to let water soak straight through, absorbing rainfall like a sponge. The water passes through the top layer into a subbase, an underground reservoir that stores a large volume of water. Another brilliant component is the green roof, transforming a standard roof into a living ecosystem. When it rains, this system works like a natural meadow. The benefits extend far beyond managing stormwater. They provide excellent insulation, create valuable new habitats, and combat the urban heat island effect. Green roofs deliver environmental, economic, and aesthetic benefits all at once. Once water leaves the surface, managing its journey is crucial. Instead of speeding it through pipes, sustainable drainage uses swales, broad, shallow, vegetated channels that slow water, filter out debris, and let some soak into the ground. Swales fit naturally into landscapes, adding greenery while quietly cleaning and moving water. For more engineered sites, filter drains, gravel-filled trenches with perforated pipes, intercept runoff, filter silt, and release water slowly. These can be left open or covered with turf, blending into surroundings. Filter drains often connect to other SuDS features, forming a chain that manages and treats water in stages. This approach ensures water is slowed, cleaned, and safely conveyed across a site. Swales and filter drains are essential, versatile tools in sustainable drainage design. Rain gardens collect runoff from roofs and roads in shallow, planted depressions, turning stormwater management into a beautiful, wildlife-friendly feature. Beneath the surface, layers of gravel, sand, and soil filter and clean the water as it soaks in. Microbes in the soil break down pollutants, providing high-level treatment. Larger engineered versions, bioretention cells, are used in commercial areas, offering both water storage and advanced filtration. These systems reduce flood risk, protect rivers, and boost biodiversity, all while enhancing urban spaces. From small planters to large installations, rain gardens and bioretention cells are adaptable, effective, and visually appealing. They exemplify the multifunctionality of sustainable drainage. For large catchments, basins and ponds provide essential stormwater storage. Detention basins are dry depressions that fill during storms, releasing water slowly to prevent downstream flooding. Retention ponds hold a permanent pool, creating wetland habitats and community amenities. Both types improve water quality by allowing sediments and pollutants to settle out. Retention ponds add further treatment through natural biological processes. These features often form the final stage in a SuDS network, ensuring water is released slowly and cleanly. Basins and ponds combine flood protection, water treatment, and ecological value. Effective SuDS design starts with understanding the site, its soils, slopes, and constraints. Infiltration tests reveal how well the ground drains, guiding the choice of drainage features. Topographical surveys map natural flow paths and identify suitable locations for basins or swales. Designers must also consider buildings' utilities and the water table to avoid costly mistakes. Working with the land's natural contours leads to efficient, resilient solutions. Early identification of constraints shapes a successful design. Careful site analysis is the foundation of every robust SuDS scheme. With the site understood, designers calculate how much water the system must handle and how fast it will arrive. They define catchment areas, use local rainfall data, and factor in climate change to size SuDS components accurately. Software models simulate storms, testing if the system can store and release water at safe rates. The process is iterative. Designs are refined until storage and flow targets are met. Balancing hydrology, site constraints, and budget ensures a robust solution. Rigorous calculations guarantee the system performs during real storms. This engineering underpins the reliability of sustainable drainage. A strong SuDS scheme links multiple components in a management train, treating water in stages from source to outlet. Source control features like green roofs and permeable pavements manage water where it falls. Conveyance elements, swales and filter drains move and clean water across the site. Site control features such as bioretention areas and basins provide main storage and advanced treatment. Finally, water is released slowly and cleanly to the environment. Each component plays a role, and together they create a resilient, integrated system. This multi-stage approach protects communities and the environment, even in extreme weather. A sustainable drainage system will fail if not built correctly. The construction phase hinges on careful planning and respect for the landscape. The first step is a rigorous site management plan, especially critical for SuDS. Uncontrolled construction traffic can severely compact the ground, rendering the design useless. Protecting sensitive areas is priority number one, with designated infiltration zones clearly marked and fenced off. Managing water during construction is critical. Runoff laden with silt can clog SuDS features. Divert runoff away from SuDS locations using bunds or silt fences. Timing of SuDS installation is a key consideration. Avoid installation during heavy rain or when the ground is frozen. This careful management sets the stage for a successful build. With proper site preparation, SuDS construction can begin methodically. Excavation is the first step for features like rain gardens. Carefully lay down the different layers. Each layer must be placed gently. For permeable paving, lay the geotextile membrane carefully. The quality and cleanliness of materials are paramount. Finally, introduce vegetation, a critical functional component. Select native species suited to the local climate. Following these practices ensures a robust SuDS feature ready to perform for decades. A key question when considering sustainable drainage systems is the cost. It's often thought that green solutions are more expensive than traditional drainage. However, a well-designed SuDS scheme can be similarly priced, or even cheaper. Savings come from reduced infrastructure needs. Plus, SuDS use fewer materials that are becoming expensive. SuDS cost-effectiveness lies in its multifunctional design. Look at the whole life cost of the system. Long-term maintenance is typically less expensive. Investing in SuDS promises lower long-term liabilities. While the direct cost comparisons are often favorable, the true value of sustainable drainage systems really extends far beyond the numbers you see on a construction invoice. The benefits they deliver are honestly wide-ranging, touching on environmental health, social well-being, and economic resilience in ways that a simple pipe in the ground just never could. The most obvious and quantifiable benefit is flood risk reduction. Every time a SuDS scheme successfully prevents homes from flooding or roads from becoming impassable, it saves communities and insurers vast sums of money in damage repairs and economic disruption. This risk reduction is a tangible financial return on the initial investment, almost like an insurance policy written into the landscape itself. Furthermore, by cleaning polluted runoff before it enters our rivers, SuDS helps to reduce the burden on our municipal water treatment plants. Cleaner rivers mean lower costs associated with treating water for drinking supplies downstream. It also helps local authorities and water companies meet increasingly stringent environmental water quality targets, which, avoids potential fines and the high cost of retrofitting large-scale treatment solutions to deal with diffuse urban pollution. The natural filtration services provided by swales, rain gardens and wetlands are a perfect example of ecosystem services, where nature does a complex job for us for free if we only give it the space to do so. The amenity and biodiversity benefits, while sometimes harder to put a price on, are equally profound. Green spaces are known to improve public health, both physical and mental, reducing stress and encouraging active lifestyles. This in turn can lead to reduced healthcare costs for the wider community. The aesthetic improvement of an area, replacing grey infrastructure with green, has been consistently shown to increase property values, providing a direct financial uplift for homeowners and developers. These beautifully landscaped, biodiverse spaces create more desirable places to live, attracting investment and fostering a stronger sense of community pride and ownership. Ultimately, the value proposition of SuDS is about building resilience. In an era of climate uncertainty, these systems make our cities safer, more adaptable and better prepared for the future. They diversify our approach to water management, moving away from a single point of failure, the capacity of a pipe, towards a decentralized network that can gracefully handle stress. This resilience has immense economic value, protecting local economies from the disruption of extreme weather and creating stable, attractive environments for businesses to invest in. SuDS are not a cost, they are a multifaceted investment in a safer, healthier and more prosperous future. Like any garden, a sustainable drainage system requires care to keep it healthy. Maintenance is typically straightforward, low cost, and less disruptive than dealing with failed conventional systems. A well-thought-out maintenance plan ensures the system delivers on its promises. Regular inspection allows for small issues to be addressed early, safeguarding long-term performance. Teams should check for blockages, erosion, and standing water. Vegetation health is critical, dead plants should be replaced, and weeds removed. Test infiltration rates every few years, and take remedial actions if performance declines. By designing for maintenance, we create environmentally and operationally sustainable systems. Lambdrove in Camborne, Cambridgeshire, completed in the mid-2000s, demonstrates how SuDS can be retrofitted into an existing housing development to solve drainage problems. Rather than installing bigger pipes, a comprehensive SuDS approach was embraced. The transformation involved integrating permeable paving, rain gardens, and linear swales. The SuDS scheme reduced runoff by 80%, solving flooding issues and improving water quality. Lambdrove proves SuDS are a practical, affordable solution for resilient communities. Portland, Oregon is a global leader in urban SuDS, particularly its Green Streets program. Faced with sewer overflow challenges, Portland chose surface rainwater management over costly underground tunnels. Green Streets retrofits rights-of-way with rain gardens. These capture gutter stormwater, filtering it through soil and plants. This reduces sewer overflows, improving river health and neighborhood livability. Portland's success shows how citywide SuDS policies can create resilient, green urban environments. We have traveled from the flaws of our old concrete-bound drainage philosophy to nature-inspired solutions for a greener, safer future. SuDS asks us to stop seeing rainfall as an enemy and instead view it as a vital resource. It's a move towards a harmonious partnership with nature. They are the building blocks of better places, landscapes richer in biodiversity, more pleasing to the eye and more resilient to climate change. The real power of SuDS lies in its holistic vision. This integrated thinking is what our future demands. We need solutions that solve multiple problems at once. It's about the kind of world we want to build and live in, to a more resilient, more beautiful and more water-wise future.